In previous videos, we've seen how to use SPSS to find the central tendency and the variability or dispersion in a data set. Here, we'll use the SPSS Explore command to find them both in the same output. In order to use the Explore command, the data have to be interval scale data. In this example, we will use the variables age and income as our units of analysis. As in previous examples, we begin on the Analyze command. On the pull-down menu, we go to Descriptive Statistics. This time, instead of choosing frequencies, we choose the Explore command. As in previous examples, we move the variables to be analyzed from the left panel to the right panel. In this case, we will tell it to do certain statistical procedures for us. It is automatically going to do the mean, the variance, the standard deviation. It will show us the minimum, the maximum, and it will find the range for us. We're going to ask it to also show us the percentiles in the distribution. That's essentially it. So let's now proceed to click OK, and the output should appear, and here it is. All right, first we have the case processing summary. It tells us how many respondents recorded their age, how many their income, how many respondents are missing, and the total, which is the sum of the valid and missing respondents. This is the important table. Here is the age variable. Here is the mean age. Here is the median age. Here's the variance. Here is the standard deviation. The minimum, the maximum, the range, simply determined by subtracting the minimum from the maximum. The interquartile range. More on that in a moment. Down here, the same statistics are repeated for the income variable. Now, the interquartile range in both cases is determined by subtracting the number at the 75th percentile. Remember, the 75th percentile is also the third quartile. We take that number, and from it, we subtract the number that's at the first quartile. The first quartile is also the 25th percentile. So for age, if you subtract 34.25 from 60, you get 25.75, which the researchers rounded to 26. And if you subtract 69.95 from 75 to 65.61, you get this as your interquartile range. This number, the interquartile range, tells us that the middle half of this sample has incomes in this range or is aged in this range. Something else to note about percentiles. Notice that in this sample, 75% of the respondents are aged 60 or below, 60 or younger. That means that 25% are older than 60. 25% are older than 60. Similarly, in this sample, 75% of these respondents earn less than 75,265.61 per year. That also means that 25% earn more than that. Down here, 25% of these respondents are younger than 34.25. That means that 75% are older than 34.25. 25% of these respondents earn $26,069.95 or less, meaning 75% earn more than $26,069.95. This is true of all of these percentile numbers. This tells us that 5% of these respondents are 25 or younger. That means that 95% are older than 25. 95% of these respondents are younger than 79, meaning that 5% are older than 79. Let me be clearer by repeating. 5% of these respondents are younger than 25. That means that 95% are older than 25. 10% of these respondents are younger than 28. That means 90% are older than 28. 25%, or 1/4, are 34.25 years. That means that 75%, or 3/4, are older than 34.25. This is the median. It's the second quartile. 50% of these respondents are younger than 45. 50% are older than 45. 75% of these respondents are younger than 60. 25% are older than 60. 90% of these respondents are younger than 72. 10% are older than 72. 95% are younger than 79. 5% are older than 79. You might have noticed that in all cases, the percentages added up to 100. Note that the number at the 50th percentile is also the median number for all variables. Finally, there are two parts of this output on which we have not commented: the skewness and kurtosis of this distribution of data. For that, we will turn to a slide shortly. That concludes this video on the SPSS Explore command.